Okay, so we started the recording, and so without further ado, I'm going to turn this over to Brandon, and he's going to talk about Python for us. So take it
Yeah,
away, Brandon.
cool. All right. Let me share my screen, and it's a pleasure to be doing this. Let's see. Okay, cool. That was the wrong one. Oh, did you see this? Great. Okay. So yeah, welcome to my talk. I wanted to go over Python 3.7 features, and that's what I'm doing. I'm a mentor for CodingNomads, and now I'll talk a little bit about me a bit more. So I have degrees in computer engineering and robotics. I love teaching Python, and I love Python itself, which is why I'm doing this talk. I think Python's a really cool language. I created the CodingNomads Flask course, which is web development using Python. It's fun stuff. Check it out. I consider myself a generalist. Software and hardware, I like both of them. They're a lot of fun. And I still can't decide what I want to do when I grow up, but probably robotics. So let's get into it. I am running with this. This is a Jupyter notebook. I'm running the latest Python 3.10 beta version. It's not released yet as a stable. And also I want to say before, when I get into this, the hope is you pick up a few things from Python 3.7 and beyond of the new features. You're not expected to remember any of this. I mean, it's just a fun talk. So let's get into it and have some fun. All right. And feel free to ask questions too. So in Python 3.7, this is probably what a lot of you are using. It introduced faster type annotations, and I'll get into those, but these were introduced back in 3.5. They were made faster in 3.7. I thought them important enough to include just because I think they're useful. And then data classes, we'll talk about that. So oh, wrong one. So for type annotations, these are also called type hints, and they're for enforcing or not types in Python. So what's the point of enforcing type hints or not? Well, a lot of other languages, there's strict use of types. So if you had a function add integers, then they would both be integers probably. In Python, you can just kind of make a function on the fly, put some variables in there, and add them up, and they print out 8. Thing is, you can put in things like strings, and that also works. It just concatenates the strings. So type hints in Python were introduced to be able to document in code the input types that are expected, the return type that's expected, and any types that a variable might take on, just kind of declared in the code. So this is the type hint syntax, and this is the same function. It's just got it just declares that a and b are integers and that it returns an integer. And it's not enforced. This isn't enforced in Python. If you put in like a float and an integer, it's still gonna do it. This is where static type checkers can really come in handy if you want types enforced. And there's things like MyPy, which will do that. And so here, if you run the same code through MyPy, it will, and you try the same thing, float in an integer, it's going to give an error that says you pass in a float, but it was expecting an integer. So I think they're pretty useful. Yeah.
Brandon, do you know if an editor like PyCharm or VS Code or Thani or any of those editors, do they also enforce type hints or not?
They don't enforce them unless you turn that option on, I'm sure. Okay. I've heard that PyCharm can allow you to do that, to turn that feature on, and it will tell you if at any point while running the code it finds that there was a type mismatch, that'll let you know.
Okay, thank you.
Yep. And there's also, you can allow multiple types at the same time. Adding a numbers function would be pretty useful. I mean, integers and floats can be added. So this is the way to do that. And so if you were to try that same 0.5 and 5, again, it would work. This isn't add numbers, but you can also annotate mutable types like lists, and you can also annotate tuples. So to do that, you have to import the typing module, and then it's a class. So, but this is sort of how you annotate a list of floating point numbers. And then this one returns a float. And that's how that works. And then the next feature is data classes, which let you write classes more succinctly. And yes, it really is more succinct. So the old way was, if you wanted to make like a galaxy class with all these properties and maybe do some fun physics math, you would have to create a dunder init, which basically the constructor of the class, and then give it all these members. This is pretty verbose. We'll see a better way. And then there's also print. If you wanted to print the instance, you could get this nicely printed string. You can also compare them, but this is all the code to do that. With data classes, it's more simple, a lot easier. So you import the data class from the data classes module and decorate a class with the data class decorator. And then this is pretty much the same code in that dunder init from last time. It's kind of like using those type annotations again to tell what types they should be. So this is pretty much all done. The dunder init is already written. There's also a post init that's introduced, so you can check whether those values were right. This is just an extra function, but this would all work. And so essentially the dunder init, dunder repr, dunder eq for equality are automatically implemented with a data class. And so this is pretty much how you create one of those planets, as you just pass in the name, the diameter, I think, and then the mass. And so I printed Earth and this other planet far off in the distance. And you can see that this all works pretty well. Of course, they're not equal, so it prints false. But this all works. So that's a pretty cool feature. I use these all the time, by the way, the data class. Frozen, you can apply to a data class to make all of the attributes it's sort of static in a way. So, well, not static, but you aren't allowed to change. So if Stan wants to change his date of birth, he can't do that because that doesn't make any sense. So that would throw an error. So that's what this frozen does. And then there's so many other features. There's breakpoints, which allows you to debug kind of on the spot. There's better precision for timing functions. Perf counter nanosecond is one example. And then there's dictionaries now preserve the insert order, whereas before they might not necessarily because of just the implementation in Python. I wanted to check if there's any questions. All right.
So we're monitoring the chat. I'm monitoring the chat. If you do have any questions, feel free to break in at the end of these. Unmute yourself. Go ahead and ask your question. If you want, if something comes up during the talk and you want to ask a question, just drop it in the chat. I'm keeping an eye on that, and I can interrupt Brandon, and we'll go on and have you guys ask your questions right then and there. So thanks, Brandon.
Cool. Yeah. So now we're on to Python 3.8. These were some of the new features that I'll talk about, which is assignment expressions, so-called Walrus Operator. It looks like a walrus. That also leads to more convenient f strings. And then Again, about type checking, there are ways to be more precise about type checking. There's literal and final keywords or classes and a few more. So first is the assign expression, the to assign, which lets you assign values to variables within expressions, meaning, so why would you want to do that? It's because if you had a variable set to a value, and then you put that variable along with some manipulations like a were 5, and you wanted to check if a was times 5 was equal to 25, and you needed that value that you calculated in that if statement, well, you would have to kind of rewrite that thing and print it out. So it's kind of a hassle, but with the Walrus operator, it makes that a little easier. So you can do it right. So you can have a variable, and then you can make another variable that's equal to some modification of a combination of a few variables. And this basically makes a new variable called myInt equal to this expression, which is, as you know, 25. And then you can print it right then and there. The value is now captured in myInt. Be careful though, because parentheses captures the expression value from this Walrus operator to the parentheses here. So this would be a whole different evaluation, because now it's this whole thing. It's checking if a times 5 is 25, which it is, and so you get the Boolean true, and then that gets set to true.
Parentheses are your friends here. Definitely.
Parentheses are your friends here.
Definitely use them. Yeah. So, and you were saying, why would somebody want to use this? Anybody, if you're coming into Python, it's your first language, it may seem a little odd, but if you're coming to it like I did, and I don't know, Brandon, what your first language was, but I came to Python from C and C++.
Yeah.
And this is, I mean, having assignments in the middle of comparisons is just par for the course for C.
Right.
So.
And yeah, I came from sort of a similar background, and I remember sometimes it would, in C, it would screw you up because it was the equal sign and the double versus the double equals.
Yeah.
So yeah, I mean, you can you can mix those together. But anyway, we're talking about Python.
Yep.
Cool. Yeah. So it is pretty convenient, the Walrus operator. So that also means more convenient F strings. What do I mean by that? If you remember, F strings let you, like say you have a few variables and you want to print some of them in a fancy way. So here I'm just kind of printing some sales stuff about maybe you're buying pants one time. So this, these curly brackets allow you to just kind of evaluate the variable on the spot. I put some alignment in here, right aligned and decimal place. So 2 decimal places. So now that I've talked about that, I have a more complex example, but here is where I'm using assignment expressions. So we start with our pants. We have the sales % off and just the normal sales tax. To do all of this math and make this nice invoice, all I have to do is make one evaluation in a F string, which might be some math, but I can assign it to another variable right then and there. And then I just keep going, and I use that same one in another one and make another assignment and go on and on and on. And that's pretty nice. I only had to do all that in one print, and I didn't need to do a whole bunch of math before that. It's pretty nice. And then one new F string feature is not exactly assignment expression, but it is being able to kind of debug your code more easily. So this equal operator would print just kind of the value of your variable in the name. So the name has this value. All right, and then more about type checking. There's the literal type, the class. And this is from the typing, just like every other type stuff. So here is where you might have a function that takes in just certain strings. And these strings have to equal a certain value or certain values. So let's say you're making a game and you want them, you allow people to paint some car, but you only have these certain colors implemented so far. So these would be able to limit you or a user to those, and a static type checker would be able to say, no, that's wrong, and handle all that. So here it works, success, no issues. This is like running MyPy with like in the terminal. And trying the same thing, running MyPy with this and passing in purple. Says you painted your car purple, and but it also gives you a warning that this isn't right. So pretty useful. Maybe you would have a function like that you can think of. This is what you could use literal for. All right. And then there's the final, which is kind of like that frozen from the data class. But let's say I only wanted one variable that was so-called final. So if I had a course and it has a name, maybe I want to change the name later, that's fine. But the ID number is pretty much going to stick. It doesn't need to change. So let's say Flask Web Development, I make the course, and I said I try to set its ID to something else. It's already been set to 73. That won't work. It would throw an error because it's final. So it's pretty nice. And then there's another sort of final, there's a final decorator, which makes it so that you can't subclass a class if you apply this final decorator. If you apply it to a method, you can't override the method, say in a subclass. Those kind of remind me of the sealed keyword in C#. Basically, it's sealed. You can't modify it or extend it. There's also positional only arguments. There's a way to tell the interpreter which ones should be positional only in a function and which ones could be keyword arguments. So those are other features in 3.8. All right, and now we're on to 3.9. This has introduced probably my favorite maybe feature, which is simpler dictionary merging, because I would merge dictionaries and it'd be kind of a hassle to do so. There's a lot of syntax around it. There's also fancier decorators, which means more possibilities with decorators, pretty much. Okay, so get into it. Dictionary merge. Union operator, pipe, which is the shift backslash key, can be used between dictionaries. But what was so bad about merging dictionaries before? What was I talking about just now? So here was the old dictionary merge. Here you have one dictionary, it's got a few names and numbers. And here's another one, it's got kind of an overlap with names or with the numbers. So if we merge these, so we're merging A we're merging B into A. So what happens is B kind of replaces this number 2. So now it's Sam and Ramit and then Sven. All right, but now there's this, oh yeah, I thought that was evaluating that. But anyway, yes, this is the more convenient pipe, and that is beautiful because that was the old way and it was kind of ugly. And then there's this in place union, so you can make B equal to the merge of A and B. And that's how that makes me feel. So fancier decorators. Now onto that. Decorators have more relaxed syntax. But what does that mean? It means, let's just go over an example first. And I grabbed this from RealPython, because I thought it was a great example. So let's say you have a few decorators, and this is just a sort of a blank decorator. Decorators make it so that you can kind of wrap a function in some other functionality, and but with just this quick, there's a decorator right there with this quick at syntax. So if you were to surround a function that prints or that returns a string, and you put shout around it, it would capitalize everything. If you put whisper around it, it would lowercase everything, and then normal is just normal, no changes. So in 3.8, decorators were more fixed. You could only do like put a shout on there or put whisper on there. There wasn't any kind of way to have one function that could apply any of those three with some like dictionary or something. So this one is just kind of demonstrating capitalizing with the shout, lowercasing with the whisper, normal. So here's what would happen in so in 3.10, you are allowed to do this. You're allowed to have a dictionary of decorator functions. Here's the function shout and normal and whisper under keys with the string to identify them. So this is totally allowed in 3.10, but not in 3.8 or in 3.9. I mean, and not allowed in 3.8 or earlier. This would throw an error in 3.8. So as you can see, I just pass in like a get the shout from the decorators dictionary, and then that totally works. This is all yelling at me. All right, and I think this is pretty fancy. So you can have like an input, say, that would ask you, do you want the shout? Do you want the whisper? How do you want me to tell this story? And then, so choose your voice, you give it a shout, and it's just screaming at you again. Cool. Pretty fun. All right, so other Python 3.9 features are annotated type hints. So if you didn't think type hints were already annotated, you can like specify the different units in the metadata for a type. There's better time zone info. So now instead of having to deal with all these date time things, you just have a zone info class, and you can give it a predefined string, and it will grab that zone info. And there's string remove prefix function or suffix function. So this call would actually remove this space dash space. But those were totally new methods introduced in the string class. All right, now we're on to finally 3.10, which is, I'll go over structural pattern matching, which is a really exciting feature, parenthesized context managers, and then a short typing improvement. Do I have any questions? I guess not. I guess we talked about that. But so structural pattern matching is Python's very own switch statement. You've probably heard of switch statements in other languages where you could check for different patterns. Well, this prevents the good old if-else purgatory, where you're if-elsing everything to check for a certain pattern. So here is the old way. Here's the old if-else purgatory. You just have if. So here's like if you're visiting a website or you're building a website and then you want to handle a status code that happens, you can figure out which one it is by doing a if-else, and then I have to do 3 if-elses until I get to here, then I just print that out. But with 3.10 and with pattern matching, the match case statement was introduced, and that allows you to do the same thing with this code. You have match this variable to these values. What value applies, or what pattern applies here? And if none of them do, then we'll go to this, we'll use this underscore throwaway variable to check that. But of course, page not found, pretty cool stuff, but it gets better. So it's if you remember, it's structural pattern matching. So it takes into account structure. It can take into account structure, like dictionaries. You have a simple dictionary like A has an ID and it's got fields. And then there's B. It's kind of like A, but it doesn't have the fields dictionary. And then there's C, which is just a number. This allows for some pretty flexible pattern matching. So I'm just going to go through all of these variables into D and do the same match with same switch statement with looking for values of D. So this case is matching the structure of A. And now I give A an ID. If it matches that, I can just grab that 4. And if it matches this fields and name, I can grab the name too, and I print those out. And you can see that works just fine. And then there's we match B, we get the ID, we can print the ID, cool. And this is just everything else, and that's just stuff. So yeah, that's I think that's a pretty exciting feature. I was like, wow, when I first tried that out, which was when I made this presentation, because it's such a new feature. So it's really cool stuff. And now there are parenthesized context managers. Not sure if how many of you have worked with context managers, but using the with statement is used for like helping you clean up resources if a file open fails to open or something else happens when trying to write to it. So there's no more of these backslashes for the line continuation when using with statements. That was a problem before. So it, like I said, to open 2 files, would I need 2 withs? In 310, well, you wouldn't need it even with before 310, but you just have a with, and then you have an open, and then a comma and an open. So that's 2. So 2 files is easy. But what if you had like 9? For some reason, you had 9 files you had to work with simultaneously. Withs before 310 had to use multiple backslashes to be able to kind of, not have a line that was 300 characters long in your code, and you have to scroll all the way to the right just to see it. So this was required, this backslash, but now with 310, we have parenthesized. Parenthesized context managers. So now all you need is to just start with a parentheses, and you can put all those files in the with and read all the lines or whatever you need to do. And all that, just that one with statement. Cool stuff. All right, and then this is the last feature I'll go over, but this is the, remember the union from the first 3.7 features. The union was to combine floats and ints or whatever kind of types you wanted to allow or expect. Before 310, that was using this to do the, to combine int and float type. And now it's just a simple pipe character. So that's a lot cleaner, I would say. So this allows ints or floats and takes in ints or floats, and it works just the same. And then the other 310 feature I didn't go over was just better error messages. So it's pretty cool, especially for beginners. If you have a syntax error and it's pointing you in an ambiguous direction, this will help a lot because it will actually tell you what's wrong, usually. So say you didn't close a bracket. It'll know that. It'll let you know that you didn't close a bracket. And that's makes coding a lot faster. All right. And that's my talk. I really appreciate your time, and I hope it was useful for everybody.
Yeah, thanks, Brandon.
Yeah.
Some of the stuff that I looked at looked like, just alternate syntax to do some of the same things, like that last bit, getting, improving the union operator, look like kind of the same, it's doing the same thing. It's just an altered syntax that makes things look a little better.
Yeah.
The structured, the structured matching and the new kind of switch statement, case statement, that was really interesting. you know, I see that as kind of a it's almost like you know, checking to see if a dictionary or even like, you know, an object or a class is the, you know, got the same kind of structure to it, at least looks the same. So, you know, so I thought was rather interesting.
Yeah, it is rather interesting. That's why I said, wow, after I used it.
So,
yeah, I mean, also, we can use this time to go over certain features you want to see sort of in the IDE in VS Code. I'm good to demo something if anyone's curious to explore something with me.
yeah, I know there was some chat going on, you know, trying to keep up with everything. I don't know, does anybody want to see any of these in more depth? Now's a chance. Now's a great chance. You got Brandon here, and I know one thing. After this is done, I want to find out how you put all this together, because this looks like I'm looking at the little arrows in the lower right hand corner, and you're just down, and then to the right and then down. That to me was an interesting thing for doing presentations. So
yeah, it's Jupyter Notebooks. It's got a slideshow feature too.
So if anybody's got anything, go ahead and unmute yourself, and you know, you can chime in here.
Can we sorry, it's Martin here. Can we have a look at the classes again?
Data classes?
Yes. Just without using the inder dunit and sorry, the dunder init, and how it kind of works now compared to before.
Oh, here. Yeah, so for this, what we were going over was, here's the old way, and then, yeah, you don't have the dunder init. So this new data class is making all that simpler with just putting this data class decorator on. And all you need to do to make a name, say a name member, you know, that would give this pretty much makes the init, dunder init, with this is the first argument, this is the second argument, third argument, and then this one is an optional one. I didn't really go over it, but this extra field is sort of the way to make something default, or make it have a default value, or this equal sign itself, it just kind of makes a default, so that you don't have to pass it in to the constructor, like so. There's four fields there, but there was one missing because that last one was optional. Is that answering your question?
Yeah. So how do you know which ones are compulsory to input when you instantiating a class out of those before? Because you had one that's optional, but it kind of looks like all the other ones you created above. So
yeah, if I wanted to, if I wanted to, I might just go over to VS Code, but I think I have to do a new share. I think it's easier to demonstrate in maybe. Let's do that. Oop, okay, bring me over there again.
There we go.
Cool. So I have to scratch. So with data classes, you do from data classes, import data class. Okay, and then I can start a new class here. Let's just call it A for now. So to make a, let's say it has like a member. A what?
Brendan, can you just make it a, can you like zoom
oh, yeah,
in a bit?
yeah.
It's pretty small right now.
Sure. Thank you, Martin.
Give it 2 more or 1 more.
1 more. There we go. Oh, come on.
And you know, you can switch away your sidebar and all the goodness so that everyone sees everything good. Command B. Yeah. Nice.
All right. So everyone can see this, right? So I just imported data class, make a new class. I haven't applied it yet. So I'm just showing you the old way of putting in or creating class. So if I wanted to have an A attribute is just equal to A. Not that A. not that A. Okay, so A equals A. No, this is confusing. A inst equals. So I can give it the value 1, and then I can just print A. Just do that. Okay, so I'm running it, and now I have, I can get that A member and just print it and see it. The alternative is data to apply the data class to a new class called B, and no, we don't need that. So that immediately goes away. And now I just do a, let's say an integer. Doesn't really matter what type you give it. Again, Python isn't gonna statically type check anything. But
Do you need to write the type though? Like, do you need to write a type there, or could you just write
yeah,
B
you
without a
can.
colon?
So this, yes, this is, I'm pretty sure this is required. You have to give it a type. If you don't care what it is, there's the any type. So this is literally anything. So if I could put that there, and then it's fine too. Again, either one is gonna, if whatever value you give it, it's gonna work, just because I don't have static type checking on. So now if I do 6, I can do the same thing, and it works. Okay, so there's A, and now here's B, and this was all I had to write. It was pretty much 2 lines with the data class. Decorator. So does that, Martin H, does that work, or does that make sense now?
Yeah, no, I was just wondering, like, if you assign multiple, like if you go to the top and you have like what's required is kind of A, B, C, D, and then in your newer version of doing it, and you kind of define A, B, C, D below,
Right.
as all as integers. How do you how does it know which is optional and which is required in your second version?
So if I had another variable here, I would specify a type first. So let's just say int, and then this would be, you can set a default value like with just equal signs. And so by default, it's going to be 3. So now if I print b int.c and do that, and it still gets initialized. I didn't even have to put it in the constructor. If I wanted to, I could change it to say 8 and play it, and then it gets changed to 8.
Okay, so if you give it a default value, it's an optional basically.
Yep.
Okay, got it. Thanks.
No problem.
And I think it's important to note too that you can do the exact same thing in class A with the dunder init just by saying self comma A comma C, equals 3, and just give it the default value there. It's the same kind of thing that you've been doing in just regular Python functions. You can always give a default value, and that way you don't ever have to assign C if you don't want to.
Mm-hmm.
Yeah, that's true actually.
Yep. So that's, like I said, I use data classes all the time. Pretty useful. They do get a little weird when you're trying to subclass from a data class. So just be aware of that. It gets iffy with the default, because I just kind of want to show it just because it's good to know. So I had another class C, which inherits from B. So the problem comes in where, well, so I have D equals, so now so now I have, oh, I didn't want to make that default. So this is the issue, is because you already have, well, before, if I looked at this, so I have B, C, and then D, and those are fine because those are defaults after a default. Or it's a, yeah, defaulted one after a defaulted one, and it's fine. But the trouble lies where, you know, inheriting from B and I have a required argument, then it gets a little tricky. And there's ways to get around it, but you just have to, you know, search around and figure it out. Probably the way to get around it is to sort of make another dunder in it. There's other ways too. But anyway, yeah, there's an error here, and it says fields without default values cannot appear after fields with default values. It's because it's just kind of following this order.
So because I have a not required value in class B before a required value in
Right.
in class C. Yeah. Right.
Yep. If this were to go away, then there's no more errors.
So when would you choose a data class over defining your own class? Or when
Well,
do you?
so if you have, maybe some of you have heard of plain old data. This is what I think of. Plain old data is just kind of like a, it's just data fields. Maybe you have an object that's like book. And if you had things like the name, which is a string, and the ISBN or whatever that's called, it's let's just say int for now. And chapters. This is sort of just, these fields don't really change. And so it's useful for that. Data classes are more flexible than that, though. You can totally, they're just like classes, but they're more convenient to define fields. The frozen comes in useful because if I had a book and it's not going to change its name, so I'd probably want to put frozen is true. But this just makes this data all nice and packed together. And it's not like I have to make a totally new class just to make, with the dunders, dunder inits and such, just to make a class.
Yeah, this I'm going to go back to C and C++. This reminds me an awful lot of structs. This
Yeah.
is just, you know, just straight up data in a nice convenient package. Then you don't have to throw a bunch of, you know, I don't need a dunder init, I don't need a dunder repr, I don't need, you know, all the other kind of goo around it. It just puts it there for me.
Exactly. Also, say you had two books, Red Riding Hood, and they have different numbers. Then from the slides, you might have remembered that these books, I'm going to give them B1, B2. These, this equality operator is, this is two equal signs. This is already implemented for you, and you don't have to do anything here. Right. Let's get rid of that. Okay. Now, for this one, oh, that's still giving me problems. Right. Should have put that in there. Okay. So, all right. I'm gonna do it. Okay. So this equality is already. It's not fun.
Yeah,
Oh man.
You need your class.
I'm having a fun time here. Okay. Yeah, I don't. Yeah. I keep pressing F5 thinking it would work. I didn't put this. Demoing is so fun when you are doing it on the fly. Okay, so these two books are not equal just because this isn't, these are the same, but I didn't have to write that. I didn't have to write the under EQ and then compare it to another one. That wasn't even necessary. Unnecessary. There's one C? Okay, I hope so. If these were the same, then that would totally work. So that's another cool thing with data classes. You don't have to write extra things if you don't need them, or if you don't need to.
Yeah, one thing, and this is going to be a little meta, but I think it's important for folks to note. I mean, you were going back and forth and correcting things and looking at the error, and then finally just said, "Heck with
Yeah.
it, we didn't need it." Just comment all the stuff that you needed, and you know, kind of on the meta thing. Exactly, when you're coding, how much of your day is doing that kind of stuff, or how much of your process is doing that kind of stuff? Because I know mine is a lot of that.
Oh yeah, there's a lot of it. There's spending 2 hours just to find the two things are misnamed.
Yeah. Yeah. So, you know, for folks who are coming up and learning this stuff, you know, don't think this is all smooth sailing. I mean, Brandon's been doing it for years. You know, he knows this stuff. He knows this stuff very well, and he's still, what's going on here? Oh, okay, I got to add this. Oh, I screwed that up. Okay, the heck with it. I don't need it. Just get rid of it all. So, you know, and yeah, I do that a
Every
lot. I'm
day.
sure. Yeah, I'm sure. You know, Martin Boyce is down there. I'm sure he does it a lot too. So, you know, this is just par for the course. You just keep hacking at it until it works. So.
I actually never make any mistakes.
Oh, sorry, Martin. Yeah, yeah. How many pairs of pants did you buy? That's
no, yeah, it's a lot of hacking away and figuring things out all the time.
Yeah, so it's a little meta, but I think it's important for folks to see that we do this type of stuff a lot. So even if it's supposed to be a presentation you've prepared, there's still a lot of, you know.
Oh yeah, there
try
is.
this. Yep.
I had to make it look nice too, and that was not even programming. It was just making a slide look nice.
Yep. So
Anything
Martin,
else?
Yeah, Martin, did that answer your question? Give you an idea what's going on?
Yeah, absolutely. I'm clear. Thanks very much.
Okay.
Awesome. Glad to hear it.
Okay.
Is there any other?
Jonathan had asked, Jonathan, if you want to chime yourself in, I can ask if you want to ask it. Doesn't matter. Okay. He asked if there were any built-in methods for data class classes.
Built-in methods. Yeah. So
obviously
there
the
was
equals.
that. Yeah. So there's this. I mean, this is any class. Any class would have this. Some classes would maybe not have that defined, but there's the built-in is this post init. I mean, it doesn't exactly answer your question. I'm not remembering what data classes might have.
It looked like the repr. So the repr was there, and it's a lot nicer than the default repr for a regular class.
Right. Yeah. To tell us or tell anybody what we're talking about. It's the printing a single book would make something like this. So it's already does all this for you. Without a data class, this would not, it would look different. It would probably have the angle brackets in there. But this is all nice. It's sort of got that, you know, here's this value, here's this value, and it's a book. That is also taken care of for you with the data class if you don't want to edit it. And then there's this post init, which actually doesn't really take any arguments, I don't think. And this is kind of the same as the init, but it's doing, you can do some of the checking here. So let's say self ISBN is less than 0, then raise some exception. That's bad.
Maybe if self ISBN.
That's right. If there we go again. Okay, so I made one of these negative. One. Play it. So it does all this checking once it's all initialized. This is an optional thing. By default, it won't do much. Built-in methods, I'm not remembering, but there is this thing, the fields. I don't know if I need this, but you can add a field and just sort of manipulate them on the spot. Fields. Yeah, I'm not quite remembering, but anyway, there's a way to sort of access just all the fields in the class. Feel like I would have remembered. I don't know. I can't get it, but fields. Oh, there we go. So yeah, so I think this is one of those built-in methods. It's turn a tuple describing the fields. If I'll just do it here. Print. I'll do it after this. Fields. Import that. Yeah. Oh, so it imported for me fields. And if I should, here we go. I'm gonna put this in. And oh well, minus this. Okay, so it printed out a bunch of goop, but I did called fields on a data class, and it gave me a field here, which is name, ISBN, and type int. So you can get all this cool metadata about a data class and kind of do some checking if you need to. Yeah.
How about what would it be? It'd be book dot dunder data class underscore fields.
Try that. It might be the same thing.
Thought it was, yeah, and I thought it was in the class, but yeah, there it is, data class fields. Yeah. I wonder if that gives you the same thing. I
think it's a function. Maybe not. Anyway, we'll see. So here's that.
Yeah, it gave you the same
and
thing.
Yeah, this seems to be the same thing.
Mm-hmm.
Yep. So it's just this hidden dunder.
Yep.
So yeah, that's the data classes.
Cool.
Yeah,
any other questions? Yeah. Other questions on other things that Brandon talked about? Anybody?
Yeah, we've got
a couple minutes left.
Type annotations, data classes, all the way up here. Walrus Operator, literal. Answer Decorators, Dictionary merge. That one's easy. Or any of these. That's what I went over. Or anything else, really.
How about questions on anything in general? Anybody got questions on?
Yeah, anything in general.
Yeah. We talked about a bunch of other things here. If there's just a general question about how something goes together. So that simple dictionary merge, is that, I mean, does that do anything different, or is it just a different syntactic way of doing the?
Yeah, it's just
the star.
Better syntax.
Okay.
I don't want all these prints to muck up the thing, but so yeah, before it was just a lot more tedious. If I just had two simple dictionaries, then if I wanted to combine those into one, I'd have to do this. So like start a new dictionary, and then this, I forget what it is, but it's like dictionary unpacking. So it would unpack all the keys and values into this dictionary, and then it would do the same thing here. It would just sort of plot A in here in this dictionary, and then plot B in the dictionary, and erase or overwrite any other keys and values. So then this would give me a new dictionary like that. But then this new Do I have Python 3? Python version. Okay, well, it's my default Mac
Wow.
version, so
Yeah.
yeah. I think it's, here we go. Okay, now I have it. Right. Yep. Okay, great. So now I can do this. C is a pipe. B, which is dictionary merging. It's all the same thing, just now with way easier syntax. And it's the same thing. Oh, wait, no. Yeah, I haven't proved that yet. Now I've proved it. Ta-da.
Okay, so it's just it's a different, cleaner syntax, but
Different,
doing
cleaner syntax.
doing the same kind of thing. The other one that you had there was the decorators, and having basically a list or a dictionary of decorators that you call,
Right. Yeah.
and access that. And I'm curious as to what kind of use case would you have for that? Because I look at it and it doesn't. I don't see a use for it as it is.
Mhm.
Maybe there's something that you could
Well,
describe.
yeah. So if you let's make a, here's my cat, by the way. Have one decorator. Two, F. So function, and the decorators are,
Yeah.
you'll learn it in the Python course, so don't be afraid if you haven't gotten to it yet. The wrapper thing, I don't think that means anything. Well, number. Yeah, even I'm having trouble wrapping my head around wrappers and decorators. But return F number +1. Return wrapper. Cool. So then if I had print to number, give me number. All right, so, and then this is decorated with the add. And then I try it. So it's going to add to 5, and then that's what this decorator does, is it just kind of intercepts the number, adds 1 to it, and gives you that.
Mhm.
So the thing with the fancier decorators is you can kind of like make the dictionary into or a decorator into, you can grab it from a like an expression. So it can be as long as you can. So let's say we have a tuple of decorators and add 1, 2. Okay. So now I have a tuple, and if I wanted to choose between the two easily, this is pretty simple and probably not like practical, but it's to get the first one. I can do a tuple, get the first one right here, and run it, and it works just fine. And then I can just grab the other one and put it right there. Grab that one, and does that. So it's just kind of more relaxed syntax. This wasn't possible before. This wasn't. You couldn't do this just because it wasn't expecting like an access of any kind or whatever.
So
I guess
I
it's
think
just, yeah.
I think you said the thing that kind of made it click for me, and that is that you can now have that be any expression, anything
Yep.
that that can be evaluated.
Yep.
And I guess that to me actually kind of made it click, because now it doesn't just have to be, oh, I'm just going to pull these out of a list or out of a dictionary
Right.
or tuple or anything. It can be any expression whatsoever, and so that
Pretty
makes it
much.
a lot more. That makes it a lot more powerful. Okay.
Yeah, and maybe even like a function that grabs a decorator.
Right.
Yeah, which isn't actually a decorator itself, but it will get one.
Yep.
I'm not even sure if that would work because of the decorator, like how it plops things in, but I'm sure it can be done.
Yeah.
It's I struggle with decorators even now. It's like,
Be interesting if that
yeah.
was actually, yeah, that'd be
Yeah.
interesting to play around with. So
Decorators are real powerful.
Yep.
Cool.
Okay. Well, we're a couple minutes past our time here. Want to make sure that everybody got questions answered. Anything else that folks want to ask?
CodingNomads related, Python related.
Yeah.
Well, I just wanted to say thanks to everyone who showed up for showing up, and
Yeah.
whoever's listening to the recording or watching, I hope you got something out of it, and it was really fun. And thanks, John, for hosting.
Yeah, always a pleasure. Thank you, Brandon, for being here. Thanks everybody else for being here. We'll have this recording done and posted here within a day or so. So if you have friends who didn't see it, have them keep looking at the forum and at the Slack, and we'll post the location here in a bit. One thing I want to make note of is that we've got another brown bag coming up in 2 weeks. And this one is going to be on uncertainty in machine learning. So if you're interested in machine learning, that's going to be a good one. Actually, that's not 2 weeks, that's 3 weeks. I'm sorry, that's on the 11th of August. So that'll be on the 11th. And then next week, actually, we're going to have just a straight up office hours. And so this is on the 28th. And we'll do that most likely at the same time, 10 a.m. Pacific. And we're just going to have some CodingNomads mentors there and instructors and other folks, and we're just going to be there for open office hours. You got a question, we got answers. And if we don't have answers, well, we still have answers. We'll give you an answer if it's right or wrong. So we endeavor to make sure all of them are right, though. So
yes.
Yes. So if you want to come to office hours just to ask general questions, meet some of the folks, love to see you there. We'll get some emails and some notifications out about that later on today. Okay, Brandon, thank you again for coming. Martin, thanks for your input. Thank you for Martin for your questions, and Jonathan when you're there. And we will see everybody hopefully in a week for our open office hours.
All right, see ya.
Thanks, guys.